Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy. Tonight I just wanted to do a quick, spontaneous video and share some of my thoughts with you. I've been in the flat earth now for probably 14 or 15 months, and one of the things that I noticed is that when you start becoming prominent in the flat earth debunking community, flat earthers constantly want to debate you. Well, I've decided that I'm going to come up with some rules for debating flat earthers. Rule number 1, I don't care about your logical fallacies. Never in the history of science has an experiment, a scientific paper, a theory, or a scientific law been disproven by claiming it was a logical fallacy. I don't care if you have logical fallacies, Tourette's. You still have to present evidence to disprove the conclusion. This is not a court of law. This is not a formal debate. Science works on evidence. Now, if you want to try and disprove something in the heliocentric model, you actually have to provide evidence for it. Number 2, you don't get to define what is and isn't science. Scientific method is a very broad category of an approach to doing science. Those of us that have done science all of our lives are familiar with it. Scientific method is not a checklist. So while you like to use a checklist for an experiment, which is how we teach 6th and 7th graders just starting off in science, how to actually do something according to the scientific method, that doesn't work on me. Those of us in the debunking community are very familiar with the scientific method. Most of us have used it all of our adult lives. So when we apply the scientific method, you can just assume that we're doing it right. So let me help you out a little bit. If you want to challenge our use of the scientific method, you have to actually challenge the validity of any particular step that we make. For example, the first part of the scientific method is to ask a question. If the question cannot be answered, you have grounds to challenge it, and then we'll discuss it with you. The second phase is that we have to propose an answer to that question. That's called our hypothesis. And our hypothesis can be anything that we want. You can't really challenge it. The third thing is that we're going to assume our hypothesis is correct, and we're going to make a prediction based on that hypothesis. Again, the only way that you can really challenge that is to show that our prediction would not logically flow from our hypothesis, assuming that it is correct. Now, the fourth phase of our scientific method is that we have to test our prediction. And we can test it any way that we choose to, so long as that it gives us a yes or a no answer, and it's falsifiable. Now, the interesting thing about the test is that it doesn't have to be an experiment. We can test it in any way we feel will give us a yes or a no answer. We can attempt to falsify our prediction. These are all valid ways of testing our prediction. And sometimes we do several of them in the same experiment. And by the way, the list that you like to use with independent and dependent variables, blah, 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 that is only one type of experiment. There are many different types of experiments. For example, we can do statistical analysis. We can do observations. These are all great ways to test our prediction. For example, if I predict that the sun will rise tomorrow, I don't need an independent or a dependent variable. The sun either will rise, and I'm correct, or the sun will not rise, and I'm not correct. There's nothing else required. Number 3, we live in a Newtonian world. Newtonian physics handles 99% of everything that we will ever deal with. And the few things that require relativistic corrections, or to get into the deeper aspects of Einstein or quantum mechanics, we're aware of what those are. We'll point them out to you. You don't need to point them out to us. You guys seem to love trying to confuse Einstein's and Newton's gravity, for example. You seem to think that it's two different things. Well, first of all, both Einstein and Newton agreed that mass attracted mass. They agreed that that direction towards the center of the Earth was down. Now, I'm going to use Newtonian physics unless I feel relativity is required. Now, if you want to argue that that's not accurate enough or that the current science is Einstein, you're welcome to do so. You can do the tensor calculus and show me that your answer will be different than mine. and I'm going to limit it to 5 decimal places. So for building a bridge, I'll use Newton. You're more than welcome to do the math to show that Einstein would give a different answer. It'll probably be 20 or 30 decimal places out, but you're welcome to show it, and then we can together decide whether or not that's significant. But unless you're willing to do the math and show your work, you don't just get to say, well, Einstein's the current science, and throw your hands up. You have to show that it's going to make a difference. Number 4, I've personally measured the rotation and the size of the Earth. So don't tell me I can't do it. I've done it. Now, let's just go ahead and say we could have faked the moon landing. It was technically possible. It's not your job to say we could do something. If you want to claim that the moon landing was fake, it's not good enough to just say we could have done it. You have to show with convincing evidence that we did do it. That's a key difference that you guys don't seem to understand. Now here's the bottom line. Simply saying that they could do something is not the same as saying they did do something. It's your job to show they did it, not that they could do it, but that they actually did it. Then I just have a yes or a no question that you have to be able to answer correctly, and I decide if you answer it correctly. This is a rock. I'm holding the rock up. The exact instant, the millisecond that I let this rock go before it starts to move, is it at rest? And the answer to that is yes or no. Those are the only 2 answers that you can give, and there's only one correct answer. If you cannot answer that question correctly, you're not ready to have a debate. I'm more than happy to teach you about motion. I'm more than happy to teach you about earth science, but you're not ready to have a debate if you don't understand the basics of motion. This has just been one of those quick little spontaneous videos that I made just because I wanted to have a quick chat. There'll be more in the future. So, signing out from Northern Michigan, this is Bob the Science Guy. Thank you again for your support of the channel. Make sure you hit that like and subscribe button down there and ring the bell icon. And I'll see you again soon. Take care.